We will now solve exponential equations. So there's two ways of doing this. You can take log to both sides and then solve by using the power rule or condensing logs. So taking logs to both sides, some information you need to recall is if you have log base x equals log base y, then your x equals y. Then you can redo or go opposite where you can log both of them to get here. And then your log base m of p, that's p times log base b of m. So that's another one to remember when solving exponential equations. Or what I like to do or try first is change the base to match your bases. So if you have base x or b of x equals b to the y power, then x equals your y. You can drop the bases. So let's go ahead and look at one example. So 4x to the 7th power. Well, this one's not a right away like, oh, it's 2. 4 squared is 7, you know, which that's incorrect. So we need to take x off of its high horse of the power. So what we need to do is log both sides. And you could even natural log both sides, but we're going to log both sides, and then we'll knock x off its high horse. So now it's a coefficient. We're going to divide by log 4. So x equals log 7 over log 4, which is the exact amount, which is the exact answer. And think of log 4 and log 7. They're just numbers. They are irrational numbers that the decimal does not repeat or terminate. And log 7 is just as if it were a 3 or a 4, you know. So think of logs as numbers. So what you're going to do is plug that into your calculator, as so, and you'll get x is approximately 1.4037. Okay, and then we have log 2x plus 1 equals log 3x to the x power, or actually this one I think would start out as this, okay? But either way, you log both sides because you want to take x's off their high horse. You want to knock them down, bring them down so that you can work with them better. Okay, so this will take a little planning. This is log 2 times this quantity, so just as if it were just a regular 2, you would distribute that through. So x log 2 plus log 2 equals x log 3. Now, here's a problem. We have two x's and then a plain old number. Just remember, log 2, log 3, they are coefficients. We just knock them to the back. So we're going to subtract x log 2 over. So log 2 equals, we can condense this. Or no, not condense it yet, excuse me. Since we have two x's, we can actually factor out an x because we want a single x. Then what we can do, I'm going to leave it as log 3 minus log 2. Now we can divide that off. And you're going to plug this all in the calculator. So x equals log 2 over log 3 minus log 2, which in your calculator, put the denominator in parentheses or in brackets so that the calculator knows to subtract these first before taking log 2 and dividing by this value. This will be approximately 1.7095. Now that one was pretty long. I know it gets confusing on what to do. Just in your mind, replace the logs as an integer, because that's essentially what they are. They are just decimal numbers. And who wants to work with decimals? I really don't. So we'll leave them in logs. Now, sometimes we can get away with raising logs to both sides. So let's explore this option. So base 2 to the x squared plus 2x equals 8. 2 and 8 are related because we can rewrite 8 as 2 to the third power. Now we can drop the 2's and focus in on the powers. Since this is quadratic, we need to subtract the 3 over and then factor. Plus 3 minus 1, so x equals 1 and negative 3. Okay, so when we're working with exponential equations and even logarithmic equations, this really tests you on how to solve your remaining equation. Once you get to an equation you can solve. So sometimes it may be linear, sometimes it may be quadratic, but with your previous lessons, you should know how to go on from here. So 3x plus 2 equals 27. Well, 27 is related to 3 because if we take base 3 to the third power, yes, third power, because 3 times 3 is 9 times 3 is 27. Since our bases are the same, we can knock them down and just look at our exponents. So x has to equal 1 in this case. So that makes sense. 1 plus 2 is 3. 3 to the third power is 27. Okay, 3 to the 2x plus 3 equals 1/27. Now, with a fraction, that would be actually 1 over 3 to the third power, but that doesn't really help us. We need to bring this up because we don't really have the same basis. So we bring that up and we negate the power. So 2x plus 3 equals negative 3. Subtract the 3 to both sides, and x equals negative 3. Lots of 3's going on in there. How about if we take 2x equals 3 to the x minus 1, okay? Again, we cannot change bases here, so we have to go back to logging. Bring down the powers, use the power rule, and then remember log 3, that is just a coefficient, that's just a number. So we are going to distribute that through. And now we need to group our x's together. We have too many x's on the playing field. So x log 2 minus x log 3. And then that's still negative. So go ahead and bring the x's together so that you need to factor out an x. So then now you have this big number, which is actually probably quite small. You're going to divide it, which if you want to save a little time, this would be x equals negative log 3 over, and if you condense those, that would be log 2 over 3, 2/3, if you would like to do that. So in your calculator, I would type in negative This value down here, that's the negative. Not this, because then you'll get a syntax error. This is the negative button. We'll go log, which is right here, 3, and then I have to close that parentheses, divided by my log, and then this would be 2/3. So we get approximately 2.7095, usually 4 decimal places is what we ask. Okay. Otherwise, if you left it in this form, you would, let's see here, oops, oh gosh, that's not what I want. Okay, if you left it in this form where you did not use the quotient rule, you'd still have log 3, and then I'd have to start parentheses and do log 2 minus log 3, so that my calculator will calculate this first and then divide it, so we should get the same answer. Okay, otherwise, if I leave out those parentheses, we get a totally different answer. See, we get a different answer because what it's doing is dividing these two and then subtracting this log 3 off. So make sure if it's in the denominator, you put it in parentheses, or just use your knowledge of the quotient rule. Okay, so there's those 2 ways on how to solve exponential equations when you have an x in the exponent. And this will conclude this video.